Hi, this is Alex from devstories.eu, OpenAPI and Swagger Ecosystem, Episode 9 of 19. If your API has 100 endpoints and they all return the exact same pagination structure, copy-pasting is a recipe for disaster. One small change to a field name means manually hunting down 100 scattered definitions across your document. The structural mechanism that resolves this tension is reusability with components. The OpenAPI specification addresses spec bloat through a dedicated root-level section called the components object. Think of it as a centralized dictionary or an internal library for your API definition. Instead of defining complex data structures, standard query parameters, or repetitive server responses in line under every individual path, you declare them exactly once inside the components object. This establishes a strict single source of truth. Before explaining the mechanics, I need to clear up a common misconception about how this section behaves. Defining a schema, a header, or a parameter inside the components object does not automatically expose it in your API documentation or your routing logic. The components section is entirely passive. It has no direct effect on your endpoints. A component only matters if an actual path or operation explicitly points to it. To pull a component into active duty, you use the reference object. In the OpenAPI syntax, this is represented by the keyword $sign before the word ref. The reference object uses a JSON pointer to tell the tooling exactly where to locate the shared definition. A standard internal pointer string starts with a hash symbol, followed by a slash, the word components, another slash, the specific category name, and finally the custom name you gave your object. Let us ground this in a concrete scenario. Almost every API requires a consistent way to return client and server errors. You want your 400 bad request and 500 internal server error responses to share the exact same structure across all endpoints, perhaps containing an integer error code and a descriptive message string. First, you navigate down to your root components object. Inside it, you open a category called schemas. Under schemas, you define a new generic object named error model and specify your code and message properties. Your generic error structure is now safely stored. Next, you move up to your API paths. When you define the 400-level response for a user creation endpoint, you completely skip writing out the schema properties in line. Instead, you provide a $ref key. Its value is the exact path to your stored schema. #/components/schemas/error model. You insert that exact same reference string into the 500-level response. You repeat this reference across your billing endpoints, your authorization endpoints, and your search endpoints. Dozens of operations now point back to a single definition. This organizational strategy extends far beyond schemas. The components object provides specific categories for various API elements. You can store standard pagination arguments inside the parameters category. You can define entire payload structures and request bodies or standard authorization requirements in security schemes. The operational logic remains identical across all of them. Define the object once in its corresponding bucket, then wire it into your operational paths using a reference. Here's the key insight. Building a maintainable API specification is fundamentally about controlling duplication. When a new requirement emerges forcing you to add a timestamp field to every error response, utilizing components means you edit the error model in exactly one place, and every operation across your entire API automatically inherits the update. That's your lot for this one. Catch you next time.